Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's group of institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. In today's lecture, let us discuss the operations on linked list part 2. So in the last class, in part 1, we have discussed the how to insert an element at the end of the list. That is how to append an element into the single linked list. Now in this session, we will discuss how to insert a node in the beginning, that is adding an element at a particular location, and then find the length of the list and display the list. Now we are adding a node at the beginning of the list. That is at the start of the list we are adding. Let us consider this simple linked list with 4 elements. Say this is the first element, this is the second element, this is the third element, and this is the fourth element. Like this, with some values in it. Here, suppose that the root element is pointing to the first location at address 2046, and some of the nodes are already connected like this. Now we are inserting one more element. Suppose that the node is already ready. Now let us see how we create the node. Here, to create the node, first we need to create a function void, and the function name what we are giving is add at begin. So here the function name can be anything. So the function name what we give here can be anything. So we are writing void add at begin function. So to insert a node at the beginning or in the middle or at the end, first we have to create the node. For example, first we are declaring one local variable of type struct node pointer type with variable name temp. So the temp variable gets some memory allocation. And by using the malloc function, we are allocating a node, say at some location 5216, and collecting this into the temporary variable so that the temp will be pointing to this particular location. So here if you can see, we are typecasting, that is we are converting, because we know that in dynamic memory allocation we have seen that the malloc return type is void, which is a generic method. But here the temp variable what we created is of type struct node pointer type. So what we are doing, we are converting the void into struct node pointer type implicitly. So here now the temp variable what we created is having the address 5216. Next, what we need to do? We need to read the elements using the printf and scanf commands. So we know how to read the elements. We have seen in our previous videos. So write printf, enter the node, and then we need to scan by using the scanf function. So here to scan, what we do? Temp to data address we are going to take. So here temp to data. So this is the data part and this is the link part. So temp to data. So into temp to data, we are going to read the value. So here, suppose that we are reading the element from temp to data address, say the value is 50. Then the temp to link value should be null. So for that, we are writing the null value is being assigned to temp to link. So here the reading is over. Now we have to deal with the connection part. So first we need to check if the root is equal to null. Then the temp value is assigned to the root. Else, now here we have to write our logic in the else part. Since the root is pointing to some other nodes at some location starting with 2046. So the root is not pointing to the null, so that the if condition is failed and now the else block will get executed. So here, suppose if already some of the nodes are available in the list, then we have to write the logic, and we will see if the root value is equal to null. That is nothing but no nodes in the list. So the temp is placed into the root, but this is our concept. So here writing the logic in the else block is our concept. So this is very simple. 2046, which should be placed here. So that the connection will be placed here. So 2046 we need to place here so that the connection will be placed here. Next, 5216 should be placed here. 5216 should be placed here so that the connection will be like this. So now can anyone say which connection first we have to place? Whether we have to connect this one first or this one first. That is the right connection first or left connection first. So this connection first is not possible. So if we store 5216 into the root, what will happen means we will lose this information. So the connectivity will get lost because the complete information we will lose, because the address is a random address and where it is created that we don't know. That's the reason. So first always we have to do the right side connection. So this need to be connected first. This is the first connection. Then we need to do the left connection. So this is the second connection. Understood? So the right side connection first, then we need to go for the left side connection. So how to perform the first connection? How is that the 2046 we have to store into this location? So what is 2046? 2046 value is the root value. So 2046 means what? 2046 means the root value. So the root value we are storing into this particular location. The root value we are storing it into this particular location. Okay, so who is pointing to this node? Who is pointing to this node? Temp is pointing to, temp to link is pointing to this particular node. So here we need to assign the root value into temp to link. So the root value is being assigned into temp to link. Here it is the temp to link means here this value is replaced with the root value. So here we are replacing this value with the, so when we say that root is equal to temp to link, the root value is assigned here. So that is being replaced with the 2046. So that this is pointing to this particular node. So the right side connection, that is the first connection is complete. Now the second connection. So right side connection is over. So next we need to make the left side connection. So in the root variable, we have to store. So in the root variable, we have to store 5216. So what is 5216? So 5216 means it is the temp value. So that we can store into this. So directly we are writing root is equal to temp. So the temp value we are assigning into root. So this is the left side connection. Here the connections are very, very important. So this is how to insert an element at the beginning of the linked list. Now let us see how to insert a node at a specific location, right? So before going to write this logic, let us see the logic for one more operation to find the length of the single linked list. So let us consider the same list to find the length. That is to find the number of nodes that are being present in the list. Int length. Here the function name is length and the return type is integer. Remember one thing, here the root variable is a global variable which is available to all the functions. Suppose whenever we are calling the length function, we can pass the root variable for each node variable we want to pass, that we can pass here. That is, we can collect here struct node pointer type root or any temporary variable we can collect. So this is the local variable. Now my root is a local variable. So we can give any name. Suppose if we want, we can pass, but anyway, since the global variable, root is the global variable, it is available throughout the application. Whereas this is the optional case, and if you want to write, then you can. For suppose you are passing locally, then you have to declare one more variable, struct node pointer variable, whose name is temp. So to the temp variable, we need to collect it into the, we need to collect the value of the root. So temp is equal to root. So we are assigning the root value into the temp. So if you declare like this, in the root, in the argument, here if you declare like this, the root in the argument, then in this case, the root is an local variable. And here the temp is also an local variable. So can we assign the root value into temp like this? Yes, we can assign. So the root value will be assigned to temp. Can we write the temp variable directly here? Yes, that is also allowed. Suppose if you are writing the temp here, then there is no need of writing this particular statement. There is no need to write this particular statement. So whatever the arguments we are passing here, if we don't pass, then we have to write the logic like this, int length. Here we have to declare the local variable temp of struct node pointer type. So struct node pointer temp. Now we can write temp is equal to root, that is the root value can be assigned into the temp. Because root is an global variable, we can assign here. As we know, root variable always points to the first node only. So is that the root variable we are collecting into the temporary variable. So the temp gets some memory allocated, and what value we are storing into the temp? We are storing the root value into the temp. So we are storing the root value into the temp. So what is the root value? The root value is 2046, which is pointing to the first node. So in temp, we are storing 2046. So that the temp will be pointing to this particular location. Now we have to find the length. How to find the length? So we have to count the number of nodes which are present in the list. For that, one more local variable we have to declare. That is int count, whose initial value we are supposed to take it as 0. So now we have to check whatever we are storing root value into temp. For suppose no elements, means the root is not pointing to any node. So the root value will be null value. So in the beginning, as soon as we declare the root value, the default value for the root is null, because the root value we are declaring as a global variable. So if you have connected number of nodes to the root, then it is not null. So if you have connection like this, then the root value is not null. So here first we are checking continuously. So we have to use the while loop. While temp not equal to null. If temp is equal to null means what? Temp is equal to null means there are no nodes in the list. So we return the count value. What is the count value? Count value is 0. So here the temp not equal to null. Yes, temp value is what? Temp value is 2046. Means what? Node is there. So already it is connected to one node. So node is there. So we have to increase the count value. So now the count will become count plus plus. So the count value becomes 1. So after counting the node, we have to send the control to the next node, if any. So can anyone say how to send the control? Very simple. The temp to link value need to be stored into the temp. So the temp to link value, we are storing it into the temp. So what is temp to link value? What is temp to link value? Temp to link value is 5048. So here this 5048, we are storing it into temp. We need to store it into 5024. Temp to link value is 5048. This 5048 we need to store into temp. So here the temp to link value 5048. So it will be stored here. So the 5048. Now again we will come to this loop. 5048 which is not equal to null. So again we enter here count plus plus. Now the count value becomes 2. Then again we check temp to link value. So the temp to link value is 9042. So that 9042 we will be storing here. Now again we come to while loop. 9042 which is not equal to null. So count plus plus. So now my count value becomes 3. Then again temp to link value will be placed into temp. So what is temp to 9042 to link 7052? So now here the 7052 value will be placed. Okay. Again 7052 is not equal to null. So count plus plus. What is my count? Count value becomes 4. So again temp to link tends to temp. So what is temp to link? 7052 to link is null value. So here the null value will get stored. So here we are going to store the null value. So once when the temp value is equal to null, sorry, here you need to replace with null. So once it comes, the count is 4. So here we have 4 nodes. That value we are going to return here. Understood? So this is how we have to return the count value. So now the return value is 4. So here the length of the list 4 will be returned. Now let us see how to insert a node at some particular location. So we have to check how many nodes are present in the list, because we are not adding the node either at the beginning nor at the end. At some particular location in the list we are adding. So here how many nodes are there? First we have to check. So here the function name we are writing is void add after. We have to add the node after a specific location. So the function name is not our interest. It is an user defined function. So we can give any name to this particular function. So this function name can be anything. So inside we are declaring one local variable to perform all the temporary operations on the node. So before the first, we have to check the location. So in which location we have to insert the node. So here we have to ask the location, printf, enter the location. Then we are scanning scanf %d. So here into the address of one location. So here we are declaring one more variable LOC which is of type integer. So here once when we define int LOC, So here first we are asking for location where we have to insert the node from the end user. That is very, very important. So first we have to check whether the location is available or not. Suppose if the location is 2, then we need to insert the new node here. If the location is 3, we need to insert the node here. If the location is 1, we need to insert the node here. If the location is 4, we need to insert the node here. If we are given a location, say 5, 55, 90, 36, so on, then what we need to do, no such location is available in the list. So we have to provide the message saying that invalid location. So how to check whether the location is available or not? So first we need to find the length of the list. So in our previous slide, we have seen how to find the length of the list. So simply we are calling the length function. And we are storing the return value into len. So we have to declare the len variable, length variable. So now once after calling this particular length function, the length is 4. So the 4 value will be stored into the length. Okay, so here the length value, it will return the length that we are collecting into len, which is defined variable len length. Suppose here it is whatever the location we are given is greater than length. So if the location value whatever we are giving is greater than 1, then we need to give an error message saying that invalid location, and also we have to message saying that the list is currently having %d nodes. So at the %d we have to. So currently list is having 4 nodes. Suppose if the location is available, then how to add the node? So if it is less than 4 or equal to less than or equal to 4, then how to add the node? First we need to create the node. Then we need to send the control to the to that particular location. Then we have to insert the node. So let us see how to insert the node at a particular location. So we need to write the logic in the if statements else block. So we need to write the logic in the if statements else block. Here we have to write the log. Now consider that, suppose say we have entered the location value as 3. So now my location value is 3. So now we have to pass the control from here to here, third location. So because we have to insert the node at this location, we have to pass the control to the third location. So how to send? So to send, we have to declare one more variable I, which is starting with value 1, and one more pointer variable P, which is of type struct node pointer type. So this is a temporary variable. So here the I value is 1, and initially P is also get some memory allocation. So P also got some memory allocated. So what is the value of P? Initially we have to send the root value into the P. So we have to send the root value into the P. Understood? So the root value is 2046. So the P value need to be 2046. So the P will be pointing to the first node. So the P points to this particular location. Now by using I, so let us write the logic while I is less than location. While I is less than LOC. What we are doing? P is equal to P2 link, and then we need to increase the I value. So this is a very simple logic what we write. Now let us see the logic. Here the I value is 1. So once when we write the logic, so I is less than LOC, I value 1 is less than 3. So P to link value becomes P. So P to link, what is P to link? P is previously pointing to this node. So P to link value is 5048. 5048 is stored here. I plus plus. So I became 2. So the I value became 2. So now again it will check. 2 is less than 2 is less than 3. So it came to this while loop, 2 is less than 3. Now P to link is equal to P. So what is P to link? 5048 link value. What is it? 9042. So 9042 will be placed here. So the link will be pointing here. Now I plus plus I value becomes 3. Now 3 is less than 3. The condition is false. So we will come out of this particular while loop. Because the control has already moved to the this particular location. So now we have to read. So we have to create the node and we have to read. So first, using the malloc function, here we know how to pass the size of struct node so as an argument. So here the results we are assigning to the temporary variable and typecasting is compulsory. So this particular creation of a node dynamically we have discussed in different topics. I don't think so. Again, we need to discuss. So here dynamically a block will get created. So here dynamically a block will get created. So here the block base address with the 50 it has got created. Understood? So here it is the temp which holds the value 5000 temporarily. So I need to write 5000 here because the temp value I am dynamically passing this into temp. So the temp will be holding 5000. The next we have to read the information. So we have to read the information into this node what we have created. So we have to insert the data part and the link part. So here already we have discussed how to read the information in, that is how to read the node data and how to store the null value into the link field. For that we are going to use the printf, enter the data into the node. In scanf, we need to write the temp to data address. So temp to data address. Say we have inserted the value 35. So what will happen? 35 will be placed here. Then this node need to be null. So null is equal to temp to link. So null value we are assigning into temp to link. So temp to link is this part. So in this particular place we are assigning the null value. So 35 is placed here and the null value is placed here. So the null value we are collecting into temp to link field. Now the connections are very, very important. So now I need to add this node at this particular location in between this node and this node. So two connections we have to make. So this is one connection. The node need to be connected here and this is another connection. So these are the two connections what we have to make. So this is the right side connection and this is the left side connection. So now again my question is which connection first, whether the right side connection we have to give first or the left side connection we have to give first. That's why if we are giving the left side connection first, then 7052. So here if we are going to give the left side connection, then this will be pointing here. So we will lose this connectivity because this node also got created dynamically at a random address. So we will be losing the connectivity. So for that, what we need to do? We have to give the right side connection first. Understood? So we have to give the right side connection first. So here 7052 value need to be placed first. So 7052 value we need to place first here into this value. So how we get 7052? That is P2 link value is 7052. So here we need to write P2 link is equal to temp to link. So in temp to link we are placing P2 link value. Then we need to place this value here. So this value here. So what is this? Temp value. So the temp value we are placing it into P2 link. So 7052 is P value and the link that we have to place is into temp. So the temp value here have to place in the P2 link value. So this is how we can insert a node at a specific location. Now let us see how to display the elements in a single linked list. Here the function is the display function. So all the operations we can perform using the temporary variable only. So here struct node pointer temp. So one local variable we have declared. So first let us store the root variable into temp. So we have to store the root variable into temp. So when we store the root variable into temp, so here the address 2046, when we say root is equal to temp, root 2046 value will be stored here. So the temp gets one memory location at some location and inside the temp root value will be stored. So what is the root value? The root value is 2046. So that 2046 is stored here. So here now let us see how to display all the elements in the node. So first we have to check whether the list is empty or having some of the elements. For that, if temp is equal to null, because if the temp already we have stored the root value, so if the condition is true, then then we need to print the message saying that there are no nodes in the list, or we need to specify the logic of how to display the elements. For that we are writing using a simple logic, that is in the else part we are writing the logic while temp not equal to null, printf percentage d. Here we are printing. So here we are printing. How we are printing? Temp to data. So here we are printing temp to data. Now observe the temp value. The temp value is 2046. So here when we entered here 2046 to data. What is 2046 to data? Is 10. So the 10 value is printed here. Now the temp value tends to temp to link. So temp to link, what is temp to link? Temp to link is 5048. So the 5048 is stored here. So we are going to place the 5048 here. And now the 5048 to 5048 is not equal to null. So again we can come here. So 5048 to data. What is 5048 to data? 20. So 20 will be printed. Then temp to link tends to temp. So temp to link. What is temp to link? 5048 to link 9042. So 9042 will be stored in the temp. 9042 is not equal to null. So temp to data 904 data 9042 data is 30. So 30 will be printed. Then we go to its link 70452. 7052 is not equal to null. So we are going to print the 7052 data here. Then we are going to go that value is null. So that's how we are going to display all the elements in the linked list. Thank you one and all. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Don't forget to like this video if you like it.